Vincent, hi.
Hi,
Welcome.
thank you.
We are delighted to have you. Vincent is a real expert also in inkjet printing, and he'll be telling us about a sort of a chemist's point of view, to the
Yes,
inkjet printing. So, good luck.
thank you. I am a chemist, so I will speak about chemistry and inkjet printing. I would like just to speak about in which extent we can use advances in chemistry to bring breakthrough in printed electronics. So I will give you some very concrete examples of system we develop in the lab when we play with chemistry and inkjet printing, because we are also interested in improving the resolution of printed patterns. So clearly, I am a chemist, so I think that the ink is at the center of the story of printed electronics. So at the beginning, we have just pigments, and you can so print pictures on paper. But at the beginning of the 20th century, conductive inks are available, so you can see, or you can observe the. Now it's possible, sorry, to implement simple electronic components in everyday life objects, such as tags, such as conductivity sensor or pressure sensor. But nowadays, we have very functional inks based on semiconductor, it's based on bioactive molecule. So now I think that printed electronics can go in an emerging field of applications such as optoelectronics, energy harvesting, but also health. So if you want to do some printed electronics, for example, for health or other emerging application, you need to print some specific inks, biomolecule-based ink, functionalized nanoparticle-based ink. So there's a kind of requirements regarding the printing techniques. First, this is very high added value inks, so no waste is required. And there's also usually this is dilute inks. So you cannot increase the concentration of, for example, of nanoparticle based ink because usually you have some flocculation. So this is fragile inks. You have to use it in a very soft conditions. If you have just a look about the different techniques of printing, clearly only inkjet printing today is really able to handle very dilute inks with high precisions because inkjet printing, there's no waste, this is top on demand, there are soft conditions when you print. So this is relevant for functional inks printing containing nanoparticles and so on. But the problem is the resolution. I agree with the last speaker. Today, for energy application, if you want just to make thermoelectric printed thermoelectric devices or photovoltaic device, you just have to mix PN materials. So you need to have very short lines, very thin lines, short widths, small widths, and to have also small gaps. Even for optoelectronics, for example, for screen, but even for field effect transistor. And in the lab, we work a lot on printed field effect transistor. And for sure, the output characteristic of the transistor is directly proportional to the inverse of the distance between the source and the drain electrodes. And for many other applications, there's a problem of resolution. For example, in the lab, we work a lot on dielectrophoretic sorting devices. So we print electrode to apply dielectrophoretic forces. And this dielectrophoretic forces is proportional to the gradient of the field of the electric field. So if you want to increase the gradient, you need first to decrease the gap between two electrodes, and you need to decrease also the width of the line. So today we are around 50 and maybe more 100 of micrometer, and I think that for all this application, this is 100 of nanometer which is required. So clearly, and as the last speaker spoke about that, we are limited by the size of the drop. Currently, for a 10 picoliters drop volume, after drying, you will have a spot of 100 of micrometer. So this is a clear issue. So you can just adjust the substrate surface energy just to improve the contact angle, for example, increase the contact angle, and just for example, to decrease the line you are able to print. So this is very interesting, and there's a lot of techniques to improve the substrate surface energy. You can use plasma treatment, UV ozone, also chemical modification